All right, let's talk a little bit about pointer assignment. In particular, how important it is to assign null to a pointer value, and then the fact that you can assign one pointer to another pointer. Right. We run the risk of our program crashing if when we declare a pointer, we don't initialize it to something, and then we end up using it uninitialized. Remember, it points to some sort of garbage value. Right. So I'm actually going to show you a code blocks example of this very same thing, and let's watch the program crash. Right. So here's our C program. Right. I'm declaring a pointer to an integer data type. So int and star PTR, remember the asterisk or the star here makes this variable name a pointer to an int. And now I'm just going to try to use this uninitialized. So in this printf, I'm going to use the pointer with the indirection operator. Well, I didn't make this point to anything, right? I don't have any other variable in my program. I didn't make it point to anything. And when I run this, actually, let's just go ahead and compile. So let's compile first, and notice now I get this warning. Warning PTR is used uninitialized. So I should heed those warnings and correct that, right? But if I don't heed the warning, and I just build and run, well, what happens is I get this showing up. I get a runtime error. Basically, I'm trying to point to some area in memory that my program is not allowed to. Unfortunately, the operating system is keeping me from accessing areas of memory I shouldn't. A read's not so bad, but what if I was trying to write to some area of memory where I shouldn't be, right? And using pointers like this is hard to diagnose if you have problems in your program. Like, in other words, if I have a much bigger program and this happened to be pointing at something else in my program's memory space, I would probably be overriding it accidentally, right? And it's not knowing why I'm getting bad results. So it's a hard error to diagnose. So what we do is we go ahead and when we declare a pointer, a safe thing to do is to make it point to null. So null is actually defined in several different libraries. Right, the null pointer is defined in standard library.h. I think it's defined in standard io.h. So the mnemonic null is already defined in the header file. And when we do that, it still points to nothing, but that nothing is always somewhere outside our memory space. It will still make our program crash if we use it uninitialized, but crashing at that point is safer than accidentally overriding something in our memory that we don't want to, right? Null is basically 0, right? You can use that as a null pointer constant. I prefer that you write the word null, right, rather than 0, but 0 is a base address that your program's never allowed to point to, right? And that's why it's a safer thing to do, because you don't accidentally overwrite memory somewhere else in a larger program, right? So once again, now, if we assign this to null and we use it uninitialized, right, so if we compile, right, we don't get a warning, right? We got rid of the warning, build and run. Our program's still going to end up crashing, right? But I didn't take the risk of this accidentally pointing to something within my program and overriding that, right? So a safe thing to do is initialize this to null, right, when you first create it. That way, if you accidentally use it uninitialized somewhere, yes, your program will crash, but that's much easier to diagnose than it is when you're overriding memory that you shouldn't be, right? So pointers can get us into trouble, right? We have to use them carefully. All right. Other thing then being is that, yes, you can assign pointers to other pointers, right? So in this example, I'm declaring 3 variables. I is an integer variable, P is a pointer to an int, Q is a pointer to an int. And so if we initialize I, if we assign the value of 15 to I's memory, and we make P point to I, right, P is now pointing to I, and we can make Q or point to P simply by assigning P to Q. And now if we use the indirection operator with Q, well, since Q and P both point to I, right, that will overwrite what's in I's memory. So you can do things like that, right? We normally don't do that, but you can make one pointer point to another. You can have multiple pointers pointing to the same area of memory. You want to be careful of that. Where we do that is we use pointers inside of function parameters to point to other areas of memory. that's where they're going to be of greatest use, right? And so in our next segment, we'll actually talk about array names and pointers with arrays.